Hi students, here we have an interesting question. This is the third question in the electricity lesson of class 10 in the CBSE and CRT textbook. Here is the question. An electric bulb is rated to 20 volt and 100 watts. When it is operated on 110 volt, the power consumed will be. So for every electrical devices, there will be a standard potential difference and power output for manufacturing, and that will be printed on the device. So this bulb, it is designed for operating in 220 volt line with an output power of 100 watts, but we are operating that in another line of 110 volt. Actually it is designed for 220 volt line. So the bulb designed for 220 volt line, if you use in another potential difference line, that is 110 volt line, what will be the effect? What will be the performance of the bulb? We can see that. We have equation for power. The electrical power can be calculated by the equation P is equal to V square divided by R, where V is the potential difference and R is the resistance of the device. Here the bulb is having output power 100 watts is equal to, it is designed for 220 volt line, so 220 volt square of that, V square, and divided by resistance. So we don't know the resistance of the filament of the bulb. We know that in an electric bulb there will be a filament like this, and it will be encased in a glass bulb without air, and some other gases like nitrogen will be filled inside. So this filament has a resistance R ohm, that is decided at the time of manufacturing, and we don't know that value that we are going to calculate. So here this R resistance of the bulb will be equal to 220 square divided by 100, that is equal to 220 square will be 48400 divided by 100. Okay, so 0 cancelled, means the resistance of the bulb is 484 ohm is the resistance of the bulb, and this resistance will not change if we are operating that in 110 volt. Whether we operate that in 220 volt line or 110 volt line, the filament resistance will not change. It will change. We know that the resistance of a bulb may change because of temperature or change in the material, otherwise it will remain constant, or the length or area of cross section. So here when we operate the bulb instead of 220 volt line in 110 volt line, what will be the new power, output power of the bulb? That we can calculate by using P is equal to V square by R. Again, so here we are operating that in 110 volt line, so that is square of that, and we have the resistance 484. So 110 square is equal to 12100 divided by 484. is equal to 25 watts. So if it is operated in the proper 220 volt line, its output power would be 100 watts. But when we operate in 110 volt, means just half of the 220, the power reduces to 25 watts. The 100 watts reduces to 25 watts. So if you calculate the ratio of the power now, say P1 by P2, it was 100 watts, now it is only 25 watts. Means the power reduces to 1/4 of the previous value. The ratio becomes 4. It means the power reduces to 1/4 of the previous value. Okay.